Hi folks, this is Barry with Barry's 8-Track and Classic Car Radio Repair, and this is going to be kind of an unusual video in that I'm showing off my shop, or at least what little of it that I can show the public. Most of it's usually a pretty good mess, but I've managed to clean up a little bit so I can show you some of my cool stuff. So I'm going to step out from behind here and get behind the camera. Okay, we're going to start with my my DVD recorders that I use to make my YouTube videos and also to make the demo videos I include with all customers' units. And we're just going to zoom in right there on that. I've got these cool Pioneer PRV X100s or PRV 100s or whatever they are. These are actually professional DVD duplicators that are used to make the movies that you watch on your DVD player. I've got 3 of these machines because you might know by now that I'm all about long-term reliability, and I always have a backup. These are dual drives, so even if one drive fails, I can still record on the other drive, and I can also record on the unit's built-in hard drive. Not a whole lot else to explain on that. That's just the DVD recorders that I use in my work. So now we're going to move on to some other aspects. I'm going to show you my bench where I work. In front of my face, whenever I'm working on a customer's machine, is this stuff here, and we'll just give a quick rundown of what all we got here. I'm going to loosen my thing a little bit. This is a Panasonic 4-channel receiver with a built-in 8-track player. That's what I use as my test receiver. It is 4-channel, of course, and if I ever have doubts as to whether a problem is with the tape or the customer's unit, I can just pop a tape right in here and just pop that tape right in there and make sure that the tape's okay. So we're going to move up a little bit. This is just your basic digital multimeter. It's a Fluke 8520. It's one of my favorites because it shows voltage and resistance. It shows the parameter that I'm measuring in nice bright red LED indicators. Nothing fancy there. And this is an HP LCR meter. This measures the inductance of coils. It measures capacitance. I can test capacitors with it. The main thing I use it for is to determine a tuner's inductance range. When I'm doing a conversion on a car unit, the car's tuner, or the radio's tuner, has to be within a certain inductance range to work with the conversion electronics, and this meter lets me know if I need to make any changes to make that tuner work with the conversion electronics. Here is this is an HP. You probably know by now that I'm a huge fan of HP test equipment. This is basically a programmable audio generator. It'll generate any frequency that I need in the audio range. Excuse me. It'll also automatically sweep between certain frequencies for sweep testing, and it goes up to about 60 megahertz, so I can also use it as an AM transmitter for when I'm working on an AM radio late at night and there's no stations on the air. I can actually create my own little mini AM station to make sure that the radio is going to pick up AM. And we're going to move up a little bit. Now this is basically an AM FM generator. This will generate carrier frequencies, modulated and unmodulated, in the entire AM and FM range. That's a fairly basic programmable AM FM generator. And now we're going to move over here. This is one of my scopes. This is a 4-channel scope, which I usually don't use for 4-channel work. This is just your basic oscilloscope for measuring audio waves and making sure there's no distortion and making sure everything looks pretty. The range is, I believe it goes up to 350 megahertz, so I can use it for virtually anything that I'm going to run into. Just below that, we have a Panasonic VP8131 stereo FM generator, and now very few shops are going to have an actual stereo FM generator because they're really not needed. If you can pick up FM, chances are you're going to be able to pick up stereo FM too, but you know me, I am obsessed with having everything that I could ever possibly need. So we have this Panasonic stereo FM generator, and it also generates AM frequencies, and I can preset just all kinds of different things and have them run automatically as a series of test signals to perform any kind of testing without having to reach up and hit these buttons all the time. And just below that is another HP audio generator. Why do I have two? Well, sometimes I want to feed two separate frequencies and see how they act together into a unit. And if not using this one for AM modulation, I can use it for just plain audio work. Below that, we have an HP 8903 audio analyzer. Now, this is a very comprehensive machine. With this, I can measure distortion levels, actual output level in watts, RMS or peak watts. I can measure just all kinds of stuff that you can't measure with any other piece of equipment. A signal to noise ratio, damping factor, just a whole lot of cool stuff you can do with this unit. You can measure just pretty much anything with it, anything you can think of. And below that, what's this? Oh, this is a box that I made myself. This is basically just a switch box that I can hook my probes to. And like, for instance, if I don't want to run a probe all the way up to the scope up here, that scope there, I can just plug my probe right into this box, and then I can use these rotary switches to select which piece of equipment that probe goes to. Right now, as you can see, I've got the probe plugged into the frequency counter. You might be able to make out the labeling right below that, frequency counter. And so nothing fancy there. It's just a little time-saving device. Over here, I've got my banana jacks that you would normally plug meter leads into, and I can that little red toggle switch. I can switch that between the LCR meter or the standard bench multimeter to save myself a little bit of time there. And below that, we just have a couple of timers. Most of my equipment is plugged into this timer, so that if I leave a piece of equipment on, it'll only stay on, for a certain length of time, then it'll shut itself off. Over here is the same type of timer for my soldering irons. I use 4 irons, different types of irons in my work. And one of my big worries in the past was I'd be at the grocery store and thinking, oh my God, I left the soldering irons on, the house is going to burn down if the cats knock it over. So this timer only leaves those irons on for, say, 30 minutes at a time, and I can set it to, any other time. This is just a little control panel that I built. It's where my test speakers can plug into. It's got phono inputs and auxiliary inputs. It's just basically a central place where I can make adjustments. Right here, I can select between common ground and isolated ground speaker systems. I've got a few warning lights there. If I'm doing something that might damage a customer's unit or my own equipment, those warning lights will light up to let me know, hey kid, you better make sure, double check things before you turn anything on. Okay, so we'll move over a little bit, and this is a real-time audio frequency analyzer, and this is normally used for live bands. They use these to adjust their equalizers to match the acoustics of the room, and it makes it a lot quicker to identify the areas of frequency range that might result in feedback. Just makes it a lot easier and faster. I use it to measure frequency response and to provide a graphic display of frequency response. For instance, most 8-track tape players have a limited high range, and so this meter allows me to actually see that range if my ears should become fatigued because I've been listening to music all day or testing units. So that's all it is. It has a built-in pink noise generator, and the pink noise generator puts out noise at equal levels at all frequencies, which is basically, is flat response, and then you can tell by the shape of the wave which frequencies are deficient and which ones are maybe a little bit too strong. We'll go above that. This is basically just a frequency counter. I use this to measure pitch. If I have a test tape that's at 1,000 hertz, I can pop that tape into the customer's 8-track player and read this on the meter, and I can say, if it's at 1,050 hertz, I know that it's running too fast. Because the ears can get fatigued, just like when you're smelling several different types of perfume or cologne, the nose after a while can't tell a difference. So all this stuff gives me a graphic indication that I can see and not necessarily have to depend on my ears. Above that, we have a wow and flutter meter, which also has a built-in frequency counter that I can use for measuring either wow and flutter or frequency. And you've seen this thing a zillion times. This is basically just my output level meter box that I built using meters off of a Yamaha 24-channel mixer. And so I have 2 of these boxes that I'm only using one right now. And above that, we have a gain phase meter, and I use this to measure the phase relationship from input to output, and there should not be any phase shift between input and output. If there is, there's a problem in the circuit, and I'll know that I need to go back in and fix something. So that's a gain phase meter. Nothing really fancy there. And now I'm going to zoom this in as much as possible so you don't see the mess. This is, where are we? Up, that's too high. There we are. Okay, this is one of 4 microphones that I have on each of my 4 test speakers. Those are Shure SM57 microphones, absolute top of the line. It's the same microphone that's used to record the instruments and drums and cymbals in just thousands and thousands of recordings that you have in your collection now. This has been the industry standard for instrument pickup, and some guys even use it for vocals because it's got a crisp sound for vocals. I have 4 of those microphones, 1 trained on each speaker. Excuse me. And if you look a little closer, you can see I have these microphones on shock mounts so that any vibration on the bench does not make its way into the microphone. Those are shock mounts that you see. So those are my microphones that I use for my speaker pickup. So now we're going to move on over to what it all ties into. This is my audio recording system that I use for my demo DVDs and also my YouTube videos. And just kind of zoom out a little bit here. Okay, we have already covered the DVD recorder. This is just a monitor that I use to see which my cameras are focused on when I'm looking in that direction. And this is basically the amplifier for my recording system. That's a Pioneer SX737. I like to use vintage audio stuff whenever possible. This is an 8-channel microphone preamp that all of my microphones plug into, and this allows me to adjust the levels of each microphone to agree with the levels required by the following equipment. This is a compressor right below that preamp there, and the purpose of a compressor normally is to even out volume levels. It's used on recording. If you've ever heard of automatic level control, all that is a compression circuit that a compressor generally automatically cuts down loud volume levels and then automatically boosts soft volume levels so that you've got more even volume. It's used for a lot of different types of effects. You'd be surprised at what compression can do. The compressor's purpose in this case is to regulate the volume of my speaking microphone. That's what I use the right channel for, the one that's got all the LEDs lit up. The left channel is simply my microphone also plugs into that channel, and that channel feeds my side chains, my compressor side chains. Now, what's a compressor side chain? Well, by using a compressor side chain, you can actually use a microphone's volume level to automatically adjust the level of something else. And in this case, I use my side chains to do what you hear on almost every radio and TV commercial ever made. That is the background music automatically dropping in volume when I'm speaking and automatically coming back up when I stop speaking. It just makes it easier for me to talk over the music without shouting and distorting. And so that's what that's for. That's the compressor for my vocal mic, speaking mic actually, and the side chain drive. And just below that we have a 31 band equalizer. That's a stereo 31 band equalizer. The one on the equalizer on top is for my is for the compressor side chain drive, and the one at the bottom with the little wavy look to it on the adjustments is the one that I use for the actual speaking microphone. And that's like, for instance, if there's too much bass in my microphone, an equalizer basically just divides bass and treble into more slices of frequency range. So this is a 31 band. That is a standard in professional studios is a 31 band. It's also called a third octave because you can change the volume of your music literally every few notes with a 31 band. So that's basically 31 bass and treble controls that it just slices the band up into narrower frequency ranges for more precise tonal adjustments. Just below that we have the mixer that everything ties into, a 6-channel mixer that's for the 4 speaker microphones, and then the vocal microphone and the side chain drive. They all go through that mixer for absolutely precise control. This is also a compressor, but I don't use this one as a compressor. I use this one simply as a noise gate, and all this does is when I'm not speaking and there's no music playing, it completely cuts the signal so that when I stop speaking, you don't hear the cooling fans from my test equipment in the background, things like that. It has an adjustable threshold to where it'll clamp down at any volume level I want. Naturally, I have it set for everything to be able to pass through, except when there's nothing going on at all, and then it completely cuts the signal out. Okay, right below here, this is just the monitor I use to play back my demonstration videos to make sure that they look okay. The speakers are there to make it sound okay. The speakers are fed by this amplifier right there. and that's just to make sure that my videos look and sound okay before I put them on YouTube or include them with the customer's unit. Right below that we have an El Cheapo DVD player, and I specifically went with a cheap home unit for this application because if my demo DVDs will play on this piece of junk, they'll play on anybody's DVD player, so that's the purpose of that. After I finish my videos, I just crouch down in front of this little rack full of equipment, make sure that my video looks and sound okay before I go any further with it. And then below that we have more compressors and equalizers, and all this is the top compressor and equalizer. You can see the color-coded tags. I follow the standard aftermarket color code. Green is left rear, purple is right rear, and then at the bottom here we have our front, and left front is white, right front is gray. And it's a lot easier to identify and make adjustments if I'm just looking at the colors instead of trying to read the lettering. So there's basically this is the audio system that I use to record my demo DVDs and my YouTube videos. It's all this cool stuff here. It's a lot more involved than just a built-in camcorder mic because it does not allow the sound of the room to enter the picture, and you don't get nearly as much reverb and echo. My recordings tend to sound a lot tighter and crisper than the videos put out by other shops. Now, it doesn't mean that my work sounds better than what the other shops do. Don't get me wrong. This is just because I'm a little obsessed with quality, and I like my stuff to sound and look as good as possible with my limited experience. And so we had this elaborate audio system that actually has more than 300 knobs that I have to constantly monitor. So now, and all this is just a this is just an RF amplifier that I use if I ever need to broadcast an FM signal throughout the house. I can, since FM plays all night long on the over the air. I usually don't need it, so therefore it's not used very much. Over here, all we have here is a couple of Hewlett-Packard power supplies that go up to 40 volts at 30 amps each. And these are the power supplies that I use to power up the customer's equipment. And to save myself a lot of aggravation and confusion, I've got one set for negative ground, and then this one is set for positive ground. And that way, I don't have to think about, okay, how am I hooking this stuff up? I just hook them up the same way that I hook everything else up, and then I hit this switch, depending on whether the unit requires a positive or negative ground. As you can see, the down position of the switch, the ground symbol is red, so that's positive ground, and of course the upper position of the switch, which is where it's mostly at, is negative ground.